Hello everyone, welcome to Next Journey with Sai YouTube channel. So today we are going to see one of the important and kind of simpler topic as compared to other topic, that is called chunking strategies for RAG. So we will deep dive down into different and the various strategies for chunking and try to understand what is the advantage and in which scenario this the particular chunking strategy is helpful. Okay, so let's without delay, let's start the topic first. Okay, before that, if someone is very new to this topic called as RAG, so let me explain you. The RAG is nothing but the retrieval augmented generation, where this chunking strategy is very much popular. So basically what we are doing, we have some knowledge base, we convert that knowledge base into embedding, and then we store this embedding into the vector database. To convert the knowledge base into the embedding format, we will use embedding format, embedding model, and we store in vector database along with the index. So let's say whenever user asks a query, okay, that query also get converted into the embedding, or you can say vector format, using the same embedding model, and then we will check the which one is the similar data is available into the vector database, and then that data plus the user query combine, and then it is it is give to the prompt, and then that prompt means this retrieve chunk plus user query combine goes to the, we form a new prompt used to the large language model, and then large language model will generate the answer. So this is what the simplistic, I can say, the architecture of the RAG, and I have already explained this kind of RAG architecture in my couple of previous session. Okay, those I have completed. So I would request please watch those video also, so your concepts around RAG will get more clear and clear. Okay, so let's now move to the next topic, that is something, what is the problem? Okay, what is the exactly the problem with the RAG? It is very easy to say that to retrieve the right context, right, from the from your custom data, okay, and LLM will generate the response based on it. But there is a real world problem in practice. It is quite difficult. Now why it is quite difficult? Because in real scenario you have, your data is very huge, right? Data is very huge. So to convert whole this data into the embedding is out of a context window, right? So again, the embedding model is again itself a kind of a your, let me just reduce the size of the font. Cannot, I think it's okay. So the embedding model is again a kind of one of the deep learning model, right? Now this deep learning model has some size, right, to or I can say it has some kind of memory to hold the data, right? Now we cannot convert the whole data into the embedded format because of this memory size. So we require to divide that data into some part, and those part is called as a chunk. But how we can divide that part, what strategy we need to use so that we will get the correct output, it is nothing but the chunking strategy, right? And that's why we will go in depth what are the different chunking strategy. Second, also the main problem, there are many embedding models. You cannot switch one embedding model to over to another, otherwise underlying understanding or the context of the information will change, because each embedding model has trained on different data. Also they have different vector size or embedding size, so and the presentation, so definitely it has main problem. So second problem is the switching of embedding model. Third is a swapping out the retrievers. Okay, so there are multiple way how one can retrieve data. So I already created one detailed video on the retriever parts. So that is something RAG retrieval mechanism. I'll paste into the description section of this video, so please watch out that. Again, the fine tuning re-rankers. So there are strategy when the data is retrieved from the vector database, which data appears first, because that has a major value, right? So we also need to work on that different, how we can use this ranker strategy, or how we can fine tune this ranker model. And the last is the rewriting problem. So there are these are, I can say, the couple of factors or the problem associated with it, which is bit difficult to give the right custom data to your LLM model. I hope you understand what is the problem, right? Now let's move to the next part. Now, the basically what is chunking? I already explained. The chunking is nothing but the you're splitting the large document or data set into smaller and the manageable pieces is called as a chunk. So before we are storing data into the vector database. So when you divide your data into the parts before storing into the vector database, this is called as a chunking. Now, why we require chunking? The first and the foremost reason, you know that the LLM context window is approximately running from 4K to 120K. Right now, it varies and it may go in near future. It depends. It varies size, but in general, I can say it ranges from 4K to 120K. So that only the relevant parts of the document can be retrieved, right? So it is very important that you should make sure that you follow, as LLM has only this window. We cannot LLM cannot understand the data beyond, or it cannot generate the data or cannot accept the data above this 120K size. Okay, so it is very important to give the data which is relevant to your context. Okay, so that's the first reason. Second is a semantic search, right? So if you properly divide your data into the right part, okay, so that the right information is getting fetched correctly. Okay, so what happened when you ask the question, vector database try to search the similar data in their databases, right? So if your data, all relevant data lies in specific chunk or in specific part, right, then it is, your chunking will be improve a lot. So therefore the chunking strategy is very important. Next is the efficient vector embedding. So in order to improve the semantic similarity, it is very important to have the good embedding store into the vector database, and that is the reason you require a best chunking strategy, so that you can store the good embedding in your vector database. So in short, I can say that if you go with the smart splitting of documents, that is the better for your retrieval and generation, because that is the main crux or the main, I can say, the underneath of any large language model applications, correct? So today we are going to touch upon what is the smart splitting, how we can split the document smartly so that my retrieval and generation part is the good. Now let's move to the types. The first chunking strategy we are going to look today, that is called as a naive chunking. Okay, so what is naive chunking? Naive chunking is nothing but the we splitting the data line by line. Okay, so we are splitting data line by line. So if you can see, I have the four sentence. Okay, the chocolate is a brown, milk is a white, you shouldn't frown, everything will be all right. So I am dividing by new line. So wherever the new line start, the first, this is my chunk 1, this is my chunk 2, this is my chunk 3, this is my chunk 4. So this is the very basic way of, creating the chunks. Now question comes, when you can use this chunk. Okay, so when I say your data is uniform, separated uniformly. Okay, so when your data is uniformly separated, okay, maybe a notes, right, or maybe a bullet point, okay, bullet point, or maybe a FAQ, okay, or for example maybe a chat log, or I can say a transcript. Okay, if you have such a kind of data, this naive chunking works very well. But if the lines are too long, okay, if the lines are too long, then you could blow the LLM token limit. Okay, so if your data is short and is in this format, then the naive chunking works very well. Okay, so this is the first strategy to, of the chunking. Okay, so let's move ahead to the next part. Second is the fixed size, or I can say fixed window chunking. So what you are doing, you are break into equal parts by word or character. Now if you look at that, in this yellow part I have 10 words, in another blue parts I have 10 words, 1 2 3 4 5 6 7 8 9 10, right? So every chunk has a 10 words. Okay, so this is chunk 1, this is 2 also have 10 words, this is also chunk 3 has 10 words, 4th and so on so forth. Okay, whatever left behind we just added as an extra. So what we are doing here, we have the fixed size and the fixed window chunking strategy. Now where you can use, let's say you have messy text term, your text is very messy, you don't know the meaning, you don't know what's happening, okay, everything, then this chunking strategy works very well. Or even if you have the scan data, okay, the scan document, okay, or you can say a bad transcript, okay, or it's say you have a long text, you don't know the context, it is only long text, right? Then this way the fixed size and fixed window chunking works very well, right? Great. Now let's move to the next chunking strategy. That is the third is the sliding window chunking strategy. So in sliding window chunking strategy, what we are doing, we have the fixed size, but each chunks overlap with one before maintain the context. And that is one of the a popular chunking strategy. Nowadays. Most of the most of the LLM engine use this, and the LangChain also provided the supporting stuff, that is a recursive splitter. Okay, so this is something called as a sliding window chunking, where you can have the one sentence, okay, and again you have a new sentence, but if you can see my yesterday, this yesterday, this yesterday and is again a part of second sentence. Even the third chunking, which is in the which is in the kind of purple color, the system is also part of that. Similarly, if you look at this until the like two, so until like from a purple is also part of the third chunking, that is the fourth chunking, that is the until like two. So you can say we divide the data into the different chunks, but we have some overlapping. We have some overlapping. Now why we are doing this overlapping? Because we want a context. Okay, if I divided data into the fixed chunk, it may happen that I lose the context, because when you say a story has some overlapping context, right? Some sequential information. To intact that context, we are using the sliding window chunking. Now when to use it? You can use it where ideas carry across the long sentence. Okay, you have one idea and that carries across the long sentence, for example, as I say essay, okay, or maybe you have some kind of narrative reports, right? So in that case, this sliding window chunking works very well. Okay, it is just like a fixed side chunking, but there are few words are overlapping to each other. Okay, so this is one of the important things you remember about the sliding window chunking. Okay, let's go move ahead. The next, oh, this is a duplicate part. Okay. Now next we have that is called as a paragraph uh, based chunking, right? Uh, yeah, this is the sliding window. Okay, sliding window done. Okay. Now next we have this is something called as a paragraph based chunking. So simple as name suggests, we are splitting the text by the paragraph. Okay, so you can see this is the two paragraph. Okay, so we say that paragraph per paragraph we can create the two chunks. So we have one chunk, I have this is a second chunk. Now the question comes where I can use the this chunking strategy. When you see the sentence chunking feels too narrow. Okay, now if you go for the sentence chunking, right, Okay, one sentence finished, this is chunk one, second sentence, and this is second chunk, chunk, this is the third sentence, my third chunk. When you say the chunking feels too narrow and you want more context per chunk, right, then that type this paragraph chunking works very well. Okay, for example, a essay, blog post, because in general meaning or in generally in English, one paragraph, when we divide any document into the paragraph with what means, the first paragraph carries some other idea, second carry this other subject is same, but we wanted to give the another angle or another next level of information as compared to the previous para. So this paragraph based chunking works very well, correct? So this way we can go ahead. So next is the page based chunking. Okay, next is the page based chunking. So here the as name suggests, we are, one second, as name suggests, what we are doing, we convert the chunk as per the page. Let's say I have the documents and that documents have multiple pages, right? So each page is a chunk. Okay, chunk 1, chunk 2, chunk 3. Now when to use this chunk? It is works very well when you have the scan document. Now you can see there are multiple chunking strategy overlap with each other. Okay, but then you ask question, when which to use? Shall I go with this, or shall I give knife, or shall I go the page based chunking? Okay, so it depends, like you have to test with the few chunking first, and if you feel that the page based chunking works very well than the my knife chunking, then probably you go to the page based. So it's a experimentation, you have to do some many trial and errors activity before you are deciding any chunking strategy. But yeah, there are few baseline, and that's the reason I'm giving few baseline to narrow down your experimentation. So wherever you see the scan document, scan PDF, or you can say slide, or you can say deck, or best thing is a book, then you can go for the page based chunking, right? Great. Now let's go to the next chunking, that is called as a structure chunking. Now when you have a structure, okay, something like this JSON format structure you can see, so each has some fixed key and value, another dictionary has another key value, another dictionary has, so it's a list kind of JSON format. Then you can use the structure chunking, and it works very well wherever you have log entries, schema fields, HTML tags, there's some coding level kind of data you have, then you should go for this structure level chunking. Okay, and as itself suggests that where you can use wherever you have JSON, right, wherever you have JSON, where you have CSV, or you have some HTML docs, there you can use this structure chunking. Understood? Great. Now let's go for the next, that is called as a document chunking. Now you are document chunking, you are splitting the text natural with respect to heading, subheading, and section. This is called as a document based chunking, and I think this is good, right? Rather than the paragraph, if you do the chunking based on the headers, okay, or the subheader or section, this will intact your context. So where you can use this uh, chunking strategy, you use where you have clear heading section. Okay, there are many couple of documents in universities or their industries, healthcare, finance, they have clear documentation. Okay, or you can say manuals, there you can use this document based chunking, or you can say the research paper, right, there you can use the document based chunking. Okay, next is the something called as the keyword chunking, keyword based chunking. So whenever you have a text, okay, whenever you break the text whenever specific words occur, that is called as the keyword chunking. Now if you look at this example, I have some note 1, note 2. So based on the keyword, let's say note, I'm breaking down the my whole data into the chunk, there you can use the keyword chunking. Okay, so where you can use this keyword based chunking, whenever the header heading level split, okay, the before chunking, wherever the heading level split aren't available, right? Now let's say you have a document and that document doesn't specify heading, then the subheading, okay, subpara, doesn't have any clarity, there you can use the keyword with the based on some keywords. Correct? Great. Next is the something called as a entity based chunking. So what is entity based chunking? We use some NER model to detect the entities like people, places and products and group them related to X around into one chunk. For example, let's say if this is some paragraph. Christopher Nolan directed the Oppenheimer, which star Murphy as a lead, and the film is received critical acclaim and several Oscar nominations. So you can see the chunk one, right? This is something related to the Oppenheimer related. Or the chunk 2 is something is a Barbie related. Or chunk 3 is the Killers of the Flower Moon related. So based on the NER entity, we can divide the data into the chunks. Rather than going for a fixed heading base or subheading base or some keyword base, we can use this NER based chunking with the related, so that what happen, so that how it helps, right? It helps to get the the backward and the forward information. So whatever information available before this keyword and whatever information available after keywords is everything is intact and I'm not losing any context, right? So where this entity base is matter, whenever you say your specific entities matter, okay, you want that I want all information related to that specific information, let's say Oppenheimer, then this entity based chunking works very well because you are not losing any information around that keyword. So I hope you understand where you can use the entity based chunking. Next, something called as a token based chunking. Now, what do you mean by token? You know that what is token? You split the text by token count using a tokenizer. Okay, so you based on the token size, you are dividing the data. So you typically want to combine this technique with maybe something called as a sentence chunking. So you can say I have multiple sentence 1, sentence 2, sentence 3, but I want everything is a part of one chunk, right? So you can use this is along with the another chunking strategy and that works very well. For example, whenever you have some unstructured data, okay, your data is a unstructured which has don't have any heading, okay, then when working with the LLM, okay, so let's say you have LLM, right? That LLM has a very low token limit, okay, low token limit, there you can use the token based chunking. Correct? Great. The next is something called as a topic based chunking. So you are using some kind of uh, you split the data into the smaller part, maybe some say sentence or paragraph, and then group related parts into the single chunks using the topping modeling or clustering. So let's say you have some data, you divide that data and then you apply some topping modeling or maybe a clustering technique to divide your whole data into the different chunks, so that during the retrieval part or generation part it is very good. Because see, every time using some advanced algorithm or you every time using some fantastic I can say approach may not work, but these are the small things, the basic things gives a very good output, and that's why I'm emphasizing on this chunking strategy. Always dividing data, splitting data into the overlapping may not work, but this may gives the good result. Okay, now when to use this? Whenever your document covers a multiple topic, okay, and let's say that topic is available across the document, okay, it is not only the first page, it may be that topic available in first page, that same topic is available into the, let's say, 1001 page or maybe 500 page, right? So your data is scattered everywhere, so you can do this kind of topic modeling and then group into the chunk wise. So this is where you this topic based chunking works very well. Okay, great. Now let's go to the next something called as a table aware chunking. Now the name itself says that you can identify the chunks table separately in JSON and create the markdown format and store it as a So let's say your document has a lot of lot of tables. Okay, then you can go with this table aware chunking by converting into the JSON or Markdown format, and then create the embedding on top of it. Right. The next is something called as the content aware chunking. So what is the content aware chunking? You are going to chunk based on the type of content, right? So you follow some appropriate rule, okay, and based on the paragraph or table list you are going to create the chunking. So let's say you have mixed format document, okay, that contain different text structure. So when you want chunks that respect the document format, okay, or meaning, so table stay whole or paragraph stay intact. So let's say you have a document, right? So this document has some paragraph, this say table, let's say this is a image. So you want all your paragraph to be intact, all your table to be intact, right, all your image to be intact, right? Then that time you can use uh, this content aware chunking. Okay, simple. The next is a context aware chunking. So what do you mean by context aware chunking? You are going to use LLM to analyze your knowledge base in a part whole and then add short and relevant context to each chunk. So this is my chunk 1, chunk 2, and you are added some context on top of it or short relevant information to on top of it. This is called as a context chunking. Now when you can use, let's say when your knowledge base or in part fits with the LLM token limit, okay, or let's say you have some complex financial document, okay, complex financial document. In that financial document you have the chunks really, and you add some information to that chunk, or you can say a kind of metadata on top of it. Okay, then this time the context chunking works very well. Okay, so till now we have covered 16. Let's go to the few more. Okay, if you are watching till now, please please be with me for a couple of minutes. We will cover whole chunking. So next is the something called as a semantic chunking. So what happened, we group the sentence or paragraph that about the same thing using the embedding similarity. So we use some embedding model, okay, and we will help to group this into the some similar, and then we convert this into the chunk and store into the vector DB. Okay, now when we can use this, whenever you see the technique like a paragraph chunking, or you can say a fixed window chunking, or you can say earlier many of the chunking fails, then you definitely go ahead with the semantic chunking. And why you go last? Because it added the additional memory, okay, or it added the additional you can say cost, because you need to create the embedding first before, okay, creating the chunks. Okay, so to identify which one is the similar, right? So using, as you can mention here, see here, the using embedding similarity, we keep the chunks topic typically focus. Okay, so that time you can go with the semantic chunking. Next is the recursive chunking. Okay, so what we are doing, we are begin the text, larger text with some, let's say, paragraph first, and if you say that resulting chunk exceed the chunk size limit, so let's say my chunk size limit is 100, I go with the paragraph and found that there are few chunks are exceed more than 100, then again I'm going to the smaller separator, something called as a sentence or word. Okay, and we convert that specific chunks again into the smaller chunk using the another splitter, and that is called as a recursive splitter. So whenever you say the your text or the whenever you have uneven length, and that is a practical or the real scenario, wherever you have uneven length or unpredictable sentence length, okay, whenever you have unpredictable sentence length, for example, let's say speeches, okay, or interviews, right, these are the generic use case, there you can use the recursive chunk. Correct. Next is the embedding chunking. So as I think I already covered using semantic, but here what we are going, we are converting chunk to embed, but here you enable all sentence first, then grouping each one with the next if their similarity is high, and splitting only when it drops below the set threshold. So in the semantic chunking, we are just dividing into the similar, but no, here what we are going to do, we embed that chunk, okay, and if you find this chunk 1 and the chunk 2 is similar, we are just grouped into the one chunk, okay, and we split that chunk. Let's say there is a chunk, okay, we split that only when the limited threshold is crossed, okay. So this way what we are doing, we as you can see here, we chunk into the embed, but you enable all sentence first, embed all first, okay, and then group each one by one, and we just split into chunk if we say it is doesn't follow the similarity with the set threshold, okay. Where you can follow again the same thing, wherever you have no document structure, okay, your document doesn't follow any structure, okay, or maybe your simpler technique, let's say the sliding window technique, okay, sliding window technique doesn't work very well, then you can use the embedding based chunking. Next we have something called as a agentic chunking. So again, we are relying on human, we are asked LLM to decide how you can chunk the text, and we are giving full control to LLM to decide what chunking strategy works very well, rather than having a human level or thought process based chunking. So when you can use, again, wherever you have find that there is a complex document, or the document doesn't have a structure, it doesn't follow any structure, as I say unstructured, or maybe you can say that human like judgment is not good, okay, then you can follow the judgment is not good, there you can follow the agentic based or LLM based chunking, correct. Next is the hierarchical chunking. This is again one of the good, so where based on the section or subsection or a paragraph we are going to the chunking. So this is let's say this is a top level chunk 1, but within a chunk we will follow a sub chunk. So let's say this is my introduction, I have this sub level chunk 1, within that there is a wide data matter, this chunk level 2, and again within that I have the bottom level chunk 1. So within a chunk we create the hierarchical kind of structure of the chunking. Now when you can use, where you have clear section and headings, there you can use this hierarchy, and it works very well than the other, wherever we also see the paragraph based chunking, right, or maybe the content based chunking. So this one is a good, okay, base of chunking to get the good level of retrieval. The next is the modality aware of chunking, means you separate the different types of context, that is the text, images and table, and create the chunking accordingly. So this is called as a modality based aware chunking. Now, as we have covered almost all chunking strategy, I hope you understand what are the different chunking strategy you can use. But as I mentioned initially, that it is not that the only one chunking works very well. And this is a bonus, that is, this is something called as a hybrid chunking. So you can combine different chunking method. You can follow embedding or LLM based chunking. So just analyze your use case. Start with the simple, then start with something complex, and see which one works very well. Again, works very well may not be always the expectation. You want a fast, right, quick, and the cost efficient. So you have to consider all these parameter, okay, and the accuracy. Please work on this metrics, and accordingly you can select the which chunking is works very well. Okay, so that is the thing. I really wanted to thank you. This one of the article from which I have created this presentation and the author. Okay, because of this I'm able to create this nice session. I hope if you like, please like, share and subscribe to my channel, and please, if you have any suggestion, keep adding your suggestion in the comment. I'll keep recording the video on that topic. See you soon. Thank you.